Pre-algebra students, welcome to our video on order of operations, and we're going to learn some algebra vocabulary. Now the algebra vocabulary comes about here because it's going to give me a chance to get to the final point of why the heck do we learn order of operations. Hold on, I totally just dropped my stylus. Okay. Hopefully you know this cultural reference here on the screen. If you don't, that's okay. Someone, I'm sure, will explain it to you. You can always show it to your parents. Hopefully they think it's funny, even if you don't. So, let's talk about order of operations. All right, good old PEMDAS. You can go with, please excuse my dear Aunt Sally. You can go with purple elephants may destroy a school. But I actually am kind of partial to please eat McDonald's applesauce because of the way the M and the D and the A and the S are together in their words. And we'll see that as we go through here. And I know you've learned this before, so jot it down and listen, and see if you learn anything new that you didn't already know. P stands for parentheses, but it really should be a G. Oh no, that's a typo. For grouping symbols, it's supposed to be an I. There we go. For grouping symbols, you're going to simplify inside parentheses, or you're going to do the math as separated by a fraction bar. So your fraction bar can be a grouping symbol, parentheses or a fraction bar. Second step is E exponents. You apply your exponents. And we're going to be talking about the difference between applying an exponent like so and applying an exponent like so. And there is a pretty fundamental difference there, something that we will look into as we go through this video. Multiplication and division as they come from left to right, and then finally addition and subtraction as they come from left to right. So that's your PEMDAS, that's your order of operations. Let's put it into action. So here we have negative and then 3 squared, and this is a strange little expression in mathematics that doesn't quite act the way you would expect, but I want you to go ahead and start trying to remember this now. Now look, in this expression, this is 3 squared, tack on the negative sign afterwards. So this is equivalent to saying negative 3 times 3. Well, 3 times 3 is 9, and then we've got a negative out front. So the value of this expression is negative 9. The value of this expression is negative 9. Not to be confused with the value of this expression. This expression is asking me to multiply negative 3 by itself. And when we multiply negative 3 by itself, we get a positive 9. So I just wanted to do that as an aside here so that we can start seeing the difference between the two. We're going to have that a lot in warm-up so we can practice with that. All right, number 2. Down here for me, 5 squared times 2 over 1 plus 2. Now, a common misconception with an expression like this is that we can cancel the 2's, and we cannot because of that addition on the bottom. And I want you... Sorry, I had to abruptly pause it because of a PA announcement just to try not to have too much of that in the video. Anyway... We've got 5 squared times 2, and then 1 plus 2 in the denominator. See, we can't take a fraction apart when it's got a sum in the denominator because that's not one denominator there. Also, I want you thinking about this grouping symbol of a fraction bar. So let's do the math on the bottom. We get 3. Let's do the math on the top. 5 squared is 25 times 2, so that's going to be 50 over 3. 50 over 3. Well, 3 goes into 5 one time with 2 left over. 3 goes into the number 20 6 times with 2 left over. And there we go, 16 and 2/3. Although 50 thirds is a perfectly acceptable answer as well. And you're going to get to the point in your math courses through this year and then into next year where we prefer improper fractions. And we'll talk about that some more later on. In this expression, this is not an improper fraction. 3 goes into 15. If it was 15 halves, that would be an improper fraction. So I want you to start looking at fractions and thinking, does this go into this? Sure it does. That's 5. And now, 12 minus negative 4. Well, minus negative, we know, is plus a positive. So put that back together, make your giant plus sign. And now I have a fraction of 16 on the top. Now remember, the grouping symbol of the fraction bar means that it's okay for me to do the math on the bottom at the same time. 2 to the 3rd power, remember, is 2 times 2 times 2, that's 8. Oh, and again, that's convenient because 8 does go into 16, that is 2. So 5 minus 2 equals 3. So the value of number 3 is 3. Last one, This one is significant. We're going to come back to this in a minute because we're going to look at a similar expression, but we're going to turn it algebraic by putting variables in it. So let's do the math here. We've got -2 squared, and it needs to be done first. Now, see these parentheses? Do not think of this as a parentheses step in your PEMDAS because there's nothing to do inside here. It's just a -2. So there's nothing to change inside the parentheses, so it's not really a parentheses step. It's an exponent step. And what we're saying is take the insides of the parentheses and multiply it by itself. -2 times itself is 4. Busy day there in the main office. We're getting a lot of announcements. I'm trying to avoid having them bother us in our video. Now the next step I'm going to do is this multiplication. Again, not really a parentheses step, it's a multiply step. We're just not showing the multiplication with a dot, we're showing it with parentheses because of that negative. What is 4 times -2? Well, that's -8. Can't write with the pointer tool, Miss LeCompte. Silly Miss LeCompte. All right, so now I've got a multiply step, and then 2 addition steps. So I have 20 plus -8 plus 3. This is the same thing as saying 20 minus 8 plus 3, and we'll do that math straight across. So that's 12 plus 3, 15. So you should have gotten 15 for number 4. All right, let's continue. Why? Why do I have to learn order of operations? Why do we use it? Why do we have it? Here's why. Finally, the mystical answer as to why we have to learn this. The order of operations is taught to prepare you for the way algebraic expressions behave. And we're going to look at an algebraic expression or two. Think about what PEMDAS is saying. And just look at this part. When I say 3x plus 7, I'm saying 3 times something plus 7. Now, if I'm plugging in the math for this, this could be $3 per person plus $7 a car to drive through the Festival of Lights at Christmas time. Okay? Or it could be $3 per rider in the car plus $7 per car to ride on a ferry. And so this would be the number of people in the car. So you can take an algebraic expression and see that we do the multiplication first, then the addition. This is why we learn. Algebraic expressions is why we learn PEMDAS. So what's an algebraic expression? Well, first we need some other definitions. So yes, this is a word-heavy video, so get copying. If you want to pause it and copy and then listen, that's fine. I'm going to go through what these terms mean. I do expect to see your definitions in your notes. A variable. It's a lowercase letter that we use to represent an unknown value, just like the x you just saw in that previous slide. Coefficient. It's a number that multiplies a variable. It sits in front of the variable. You don't need a dot. You don't need anything of that sort. If you go back to that expression we just looked at, that would be the number 3. Constant. It's a number on its own. So it doesn't have any other values on it. If it's a minus, it's a negative, and if it's a plus, it's a positive. So in our 3x plus 7, our constant would be positive 7. Expression. It's a mathematical phrase that includes at least one operation. So 8 plus 9 would be an expression. But 3x plus 7 is a particular type of expression, and we'll talk about that in a minute. And then finally, term. It's a number, a variable, or a product of numbers and variables. And terms in an expression terms are separated by addition or subtraction. So terms are separated by addition or subtraction. We'll look at an expression and talk about its number of terms in just a minute. So here's a couple more words real quick. Base, exponent, and power. So this entire expression is a power. It's x to the nth power. That's how we read this. X to the nth power. And we say nth because we don't have an n value. X to the nth power. So that whole thing is a power. The x is the base. Think about like a lamp or a fan sits on its base. It sits on the line, that base value. And then, of course, the n is your exponent. Sorry, I accented the wrong syllable there. Exponent. Your exponent, and that tells you how many times to multiply the base. Those are all, should be kind of review terms for you. If you learn to call this a base and you get that in your head now, you're going to thank me when you get to logarithms in Algebra 2. You can come back and tell me all about it then. All right. An algebraic expression. The reason it has become algebraic and not just an expression is because it has variables in it. An algebraic expression is called algebraic because it has a variable or variables in it. In this case, it's actually only a variable, so let's fix that real quick. A variable, because the x is the same variable twice, but these two terms here are not what we call like terms, and we're going to come back to that later. But I want you to remember something from a few slides ago. Go back and look at example number 4. Wow! Example number 4. Squared plus 4 times negative 2 plus 3. So there's example number 4, and look at the relationship we have here. Look, x is negative 2. If I take and I replace this x right here and the x right here with a negative 2, I get the same expression I had before. Now, so if you look at this, this is a perfect example of most of your order of operations. Okay, there's no parentheses, so we don't have that. But there is an exponent, and yes, you do that first. So you would square your x first. Then you would do the multiplication of the 5 times what you got and the 4 times that x as well. And then finally, you do the additions right here. Ah, that one's wrong. Oh man, it won't erase it, so I have to do this. Okay. And I missed, it was right there. Okay, so I know I just kind of marked this all up, but hopefully you're seeing what I'm telling you. So finally, we know why we have to know the order of operations, because you need it in order to learn algebra. And while algebra may not be something you're going to use every day in your life, it's going to help you learn how to organize your thinking logically and how to think abstractly, how to think about things that you can't actually hold in your hand but are important concepts for you to be able to understand. Sorry, I know that was kind of deep. Okay, but that's it for our video. Hopefully you enjoyed learning a little bit about the vocabulary. Yes, you need to know the vocabulary. And it's entirely possible that you might see some sort of check or assessment, maybe possibly when this video is due, but I'm not telling you that for sure. I'm going to finish out with a little bit of one of my all-time favorite songs. So, enjoy. And if you're done watching, you can go ahead and turn it off. Otherwise, you can get up and dance.